This now telling me that October it was fine, but still it is come in the September. There could be a possibility that it is come in the December or January once again. So therefore, I would not wait. This has to be analyzed immediately and understood. Even though during one particular instance, if there is a control, there is a data outside the control limit, I would not be complacent and say that it has happened only once. I need to analyze the reason that why it has come, and therefore I'll be able to proceed further. So if there's a special cause, I need to know that special cause. I need to know that. I might not be able to find the solution right now, but yes, I need to know that why it has come. And then it happens, then I might be able to conclude that this is because of that. But I will not sit, wait this to happen. This is very, very important. Even though you're doing really well, even though the special cause is good for the process, but I need to know the reason why. And that's what these control charts are for. So this is an example of P chart that we have done. Now let's do the C chart. So C chart is to be done when it is defects, okay, and my subgroup size is constant. So I have data for 50 weeks. I put it on mini tab. So I go to stats, I go to control charts, attribute charts, and I click on the C chart. So in variables, I put defect. So C chart will not give me an option to put the data points because it understands that the data points are same for all the months. So it is not asking for it. Okay. So I click on scale and put the number of week. So this is the C chart. What does it tell? Can someone help me with this control chart?
It tells the number of defect in a given time frame, and at point 1 the system is out of control, otherwise the system seems to be in control. Most of the points are on the upper side of the average and some of the points are on the lower side, and lower control limit cannot be less than 0. The minimum point is definitely 0.
But we do see a lot of defect points touching the lower control limit.
Yeah, so that is my question. That's what I wanted to know from you, that whether you can. So two questions.
This is a okay.
Let me just ask two questions to understand that we have concluded the control chart. So we all know how many data points are outside the control limit in this control chart.
One.
There's only one. Yeah, it is already highlighted in red, which is outside. You can see the upper control limit here. However, did you see some data points which are on the borderline, on the lower control limit?
Yeah.
Yes.
Like week 6, week 11, week 16, week 20, and 21. Week 21. So what would you do in that case?
So this is a case of Poisson distribution. So number of defects can never be negative. It can never be less than 0.
I'm not talking about Poisson distribution here. I'm just talking about what would be our scenario. What in that particular case, what we would do.
We will check things and those dates regarding the process is any unstable or
so
Simar, so basically there are 8 data points where we have 0 defects. We would want to analyze and replicate that in the process, because those are the days where we have reached a 0 defect. We want to understand what is that reason on that particular week that there were 0 defects.
Which means you are concerned. You're not leaving it.
No. Yes, we need to check that. Yes.
Yes, it will.
We cannot just leave. Like if there is something which is not moving in the same pattern like the others within the specific within the near about the average, we need to look into it, especially when it is touching the LCL as to why it's 0.
Absolutely. So in a nutshell, even though these data points are within the control limit, which are on the borderline, but I would like to, when I will conduct a meeting, when I will be asking questions, I will be concerned about these because these are very, very near. And since these have not been addressed, and that's the reason it has come again and again here. Okay. So it can come again, and that's the reason. Apart from this is for sure, I would also be concerned about these. So in your scenario, so I have taken example in such a way so that you'll be able to understand that even though if the data points are on the borderline, I will not wait, I will not sit and say that, I can go ahead and work on only of one of the data points. So I'll be more concerned about these data points also, because these can ever be converted into a lower control limit.
And Simar, just a question. Looking at this data, even if we just have 8 data points right on the LCL, but even for the other data points, it's quite scattered. We have a lot of variations. So should we be concerned about that as well?
So in the control phase, although there is a variation in this data, okay, you would not find this kind of a control chart at the end of during the control phase of your project, because then you would not see that kind of variance. Since the sample count is only very less, you see it's only 0 to 9. Okay, that's the reason you would see a lot of variation. But still looking at this example, the Minitab also itself says that this is a normal cause. Okay. I need not to worry about these variation, because there is a special cause that I'll be first concerned about, and second is that what we just talked about on the borderline.
Perfect.
Okay, though there is a variation, but that is a normal cause, that is not a special cause. Okay, so control chart, one thing which I did not discuss earlier, and that there was a reason why I did not do it. Control charts can be used in the measure phase as well, to show first of all that how much variation, that how much special cause variation that I have, and then I can use it in the control phase as well to do a comparison sort of a way, that earlier how much was a special cause and now how much was a special cause. Okay, so you would typically find these kind of a control chart during the measure phase, wherein you would see there is some amount of variation and there is a special cause as well. But generally, when you have already improved the project CTQ and come up with the structural solutions, wherein you have done a lot of analysis, a lot of hypothesis testing, done test of equal variance, prepared an FMEA, have done the design of experiment, therein you won't find that much variance. Therein you won't find at either one of the data points outside control limit. Very rare you would find. If you find, you would try to work on it. Okay, so this is just an example where you see there's an oscillation, okay, up and down, but very rare you would see when you have implemented the right amount of tools and implemented the structural solutions and use all the perfect combinations of FME and the design of experiments. Okay, so this is an example of C chart. Now the last chart which is left for discrete is the U chart. Okay, so in U chart, I have the example. U chart, the subgroup size varies, okay, but it is a defect. It is the replica of P chart. So I click on this thing. I click on stats. I go to control chart, click on attribute charts, and click on U chart here. Okay. Don't click on LANI U. Click on neither on U chart diagnostic. Just click on U. In the variable, put the defects that we have. In the subgroup size. Then I select the weak number. And this is my U chart is. So you see an amount of variation. Do you find any sort of special cause variation here?
There's one.
And there's one which is over the lower control limit.
Absolutely. So you would also, you'd be very, very concerned about this data point. Okay. However, you will not leave this data point as well, because this is near the borderline. Okay. And this is not being addressed. That's the reason it has come again here. There is a peak here. So this U chart is telling me that what are the data points which are outside the control limit and what are the data points which are within the control limits. So the interpretation of all the chart remains the same. It's the upper control limit and the lower control limit that we have to consider. It's just that the path is different in Minitab, and it is to be used at a stage where it is required. The prerequisite is that what it is. So we have concluded the control charts for discrete data, NP chart, P chart, C chart, U chart. Okay. So I would go back to the presentation. So we have concluded defective constant NP, defective non-constant P, defect constant C, and defect non-constant U. Does anybody has any question? The variable control charts are little complicated than the attribute ones, but that is also very simple. If we understand it well, then we'll be able to remember it if you practice it regularly. But these are a little different from the attribute ones. So if you don't have any questions on the attribute ones, we can go to the variable ones.
Simar, can you go to the U chart which we just prepared? The one which...
Yeah, sure, I can.
Can you go to the adjacent points which is next to 1? I mean the adjacent parallel points to 1 or the defect line? Yeah. The next one, I mean the one which is directly in the same line as in the horizontal line.
This one?
No. Just the one which at the top.
Okay.
Yeah. Okay, so sample is 11, 3.5, and can you go to 1?
So it's a decimal. It's a decimal that has considered. Yeah. So let's look at it. That's a good point. Good way to look at it. So this is for sample test 1. Okay.
Yeah.
And this is for sample test 11. Okay. Let's read it. 1 and 11. So 1 I found 14 defects and 11 I found 7 defects. However, here the subgroup size was 2 and here the subgroup size was 4. Okay. So it depends upon the subgroup size as well to calculate that how many defects that we have come across. Okay. So that's why this might be in decimal and that's when it is not being captured. So UCL is 3.337. Okay. But it has not reached to the outside the control limit. And that's the reason the tool, it says that during this week, okay, you might be cautious about it because it is very, very near to the upper control limit. But yes, this is the first priority and these two can be looked at as well. But it is not a concern of worry at the moment. This is the most important thing to look at the moment.
Okay. And one more question. So UCL, as in why are we seeing a square as in, so if the UCL is 3.37, that should be a linear line, right? And
yeah.
why?
So So the answer to this question is in the U chart and in the NP chart, the subgroup size are not constant. It is variable. And that's the reason you see this line. When we were using the C chart or the P chart, then you would find this line as constant.
Mm-hmm.
Okay. It is because of the subgroup size. That's the reason you would see this line as coming here and there.
All right.
Okay.
Yeah.
So you look at the C1, you see straight line here. Okay. You see P line, P chart, which is okay. But NP is on the fixed constant data points. That's why you see straight line. Okay. So when the subgroup sizes are same during the period of time, then you see a linear line. Okay.
Yeah.
So we have concluded the types of control charts for discrete data, and now we will conclude the control chart for continuous data. So the first one is the IMR, okay, which is called individual moving range. This chart is to be done when we have only one subgroup, which means we are doing it for the entire data, wherein we don't have multiple subgroups. So I'll explain what is subgroup here. So let's look at the continuous data we have. So I will consider this raw data as the continuous data. So I will select this entire data and put it on Minitab.